problem F. We are going to split this into 3 separate problems, so to speak. With that negative 12 and 48, do not bring the negative 12 down to the denominator. That is not a negative exponent, that's just a negative number. That's going to reduce to negative 1/4. And I'm not going to write the 1 there unless I really need it at the end of the problem. With the x's, the x to the 7th is going to come up above, the x to the 4th is going to go down below. And after we do that little switcheroony, there will be more x's up in the numerator, giving us x to the 3rd. You can see I don't have to have that 1 written now, that there's something else up in the numerator. And with the y's, that y to the -3rd can come down to the denominator, and we can have 4y to the 8th down there, because 5 plus the 3 that are coming down make 8. Okay, now we're going to start moving on to a little bit messier of a problem. When we have a more complicated expression such as this, I like to clean up or work inside the parentheses first, obeying the order of operations. I'm going to leave the negative 3rd power outside. Now, the 3/6 reduces to 1/2, leaving a 2 in the denominator. With the x's, the 2 upstairs come down to the denominator, joining the 5 that are already there, giving you x to the 7th. And with the y's, y to the -7th comes up to the numerator, joining the 4 that are there already, and we have y to the 11th. Now, I've taught this in different ways over the years, but what I'm going to say now is instead of showering the whole negative 3 in, I only want to shower in the negative. And what that's going to do is it's going to give you a y to the negative 11th, 2 to the negative 1st, x to the -7th. And since everything inside will have a negative exponent, that means everything in the parentheses is going to want to switch places from the numerator to the denominator. And the net effect that you get is the fraction inside flips over. And then it's to the positive 3rd power. So in a sense, we're using up the negative. Now I'm going to cube everything inside. 2 to the 3rd power makes 8. We're going to have x to the 21st power because we multiply exponents when it's a power to a power. And we're going to have y to the 33rd. So anytime I have a negative exponent outside and kind of a complicated expression inside, I only bring in the negative first in step 1, and then a little bit later I then bring in the 3, and do it as a 2-step process. I'd like to finish off this review with 3 short and somewhat simple questions, but they're questions that are very commonly missed. In this first problem here, 5x to the -3rd, it simplifies as 5 over x to the positive 3rd power. Recall that a negative exponent, or any exponent, only goes with a variable that's directly next to, and that negative 3 does not apply to the 5. Only the x portion of the variable term goes down to the denominator. In this second problem, the common mistake is to go 49 to the 14th power, but this is just 7 to the 14th power, because if you think about it, x to the 3rd times x to the 11th is equal to x to the 14th. Well, if the x's stay the same, shouldn't the 7's stay the same up above? And on this last problem here, we see this exponent of 0, which makes us want to say that the answer is 1, but this is really 5, because you really have 5 times blob to the 0 power, and only that blob turns into 1. So that's really 5 times 1, which is equal to 5.